Hi students, in this video we are going to learn about geometric progression. We are just going to see the definition of geometrical progression. A sequence A1, A2, A3 and so on An is called a geometric progression if it satisfies this condition. The condition is if each term is non-zero and ak plus 1 divided by ak is equal to r, that is constant for all k greater than or equal to 1. The constant ratio, this constant ratio is called its common ratio. It means that in case if we put k value is equal to 1 means in the numerator we will get a2 divided by a1 which is equal to r. In case in place of k if we substitute 2 we get a3 divided by a2. In AP, in arithmetic progression, in order to find out the common difference, we subtract like this kan minus 1 divided by an, that is a2 minus a1, to calculate the common difference. Here we are calculating common ratio by taking the second term divided by the first term. That common constant ratio is called as common ratio. So each and every term will have its common ratio. If the first term is given, let us say first term is given as 2 and the common ratio r is equal to 3 means we can form the GP by forming like this. Along with the first term we should multiply 3, so we get 6. After, in order to get the third term we must multiply the second term by the common ratio, so we get this, and similarly it keeps on going like this. So in order to form the GP we need the first term and the common ratio, using which we can easily form it. I hope you can understand the geometrical progression definition, and we will see the important notations that we normally use in a GP. In a GP we usually denote the first term by A and the common ratio by R and the nth term by Tn. So these are the notations we will use for the some technical words. For example, first term is denoted as A, common ratio is denoted by small r, and the nth term, as you know very well, it is denoted as Tn. Now we will see a problem related to this concept. The GP is given as 2, 6, 18, 54 and so on is a GP. Then we know that A is the first term is 2, it is hence A is equal to 2, and common ratio is calculated by dividing the second term by first term, that is 3. Minus 16, 4 comma minus 1 is a GP, in which if we try to find out the value of A is equal to minus 16 and common ratio is given by 4 divided by minus 16, which is minus 1 by 4. I hope these information, these two example give the basic information about GP. Now we will see how to find the nth term of a GP. Let us consider a GP in which the first term is A and the common ratio is R. So we know that first term is A and A can be written as A into 1. You know that anything power 0 is 1. Here we are writing R power 0. Instead of writing as 0, we are writing it as 1 minus 1, because first term 1 is there and here this 1 denotes like this. Sorry, we are trying to write this first term in terms of this number, and then we are trying to write the second term of the GP. Second term is denoted as T2. We know that along with the first term we must multiply the common ratio, we get AR. This AR can be written as A into R power 1. In order to bring this serial number into it, we are writing this 1 as 2 minus 1. Similarly, we are writing third term. You know that third term can be written by multiplying the second term by the common ratio, so it becomes AR square. In order to bring this serial number into the formula, we are writing this 2 as 3 minus 1. Similarly, if we write nth term, Tn is equal to A into R power n minus 1, because if it is third term means 3 minus 1. T2 second term means A into R power 2 minus 1. So if we want to find out fifth term, it can be written as T5 is equal to A into R power this power 5 minus 1. I hope in this way we can write the nth term formula for GP. I hope you understood this concept. Now we move on to some problems related to the concept we learned. Find the 9th and nth term of the GP. We know that nth term formula is Tn is equal to A into R power n minus 1. In order to write the nth term, we need the value of first term and the common ratio. If we know these two parameters, we can write the nth term. So that is what is given here. Based on the question, we can say A value is equal to 3 and we can calculate R value as second term divided by first term, that is 6 by 3 is equal to 2. We got the required values and they are substituted in the corresponding place. So we got the nth term of this GP, using which we can find out the 9th term. 9th term means in place of n we can substitute 9. So we get this expression. In place of A we substituted 3, in place of R we substituted 2, and in place of n we are substituting 9. 9 minus 1 is 8. So when we simplify it, we are getting this answer. I hope you understand the concept clearly. Now we move on to the next concept. The nth term from the end of a GP. Here in the previous one we have calculated nth term from the beginning of the GP, but here we calculate nth term from the end of the GP. Again we consider A as the first term, R as the common ratio, and L is used to denote the last term of a GP. You know that GP can be formed using common ratio and the first term. In case if we take first term as A, second term is calculated by multiplying the first term by common ratio. Again third term can be obtained by multiplying the second term by common ratio R. Like that it keeps on going. In case if we assume that this fourth term is the last term, means if we want to move from fourth term to third term, you just observe it, we have to divide the fourth term by R, so that we get AR square. In case if we want to move from second term to third term, we are multiplying it by R. In case if we want to move from third term to fourth term, third term is multiplied by R. So now we are going to come from the last. So if we want to move from fourth term to third term, we have to divide the fourth term by R. In case if we want to get the second term from third term, means third term should be divided by R. This logic only we are going to apply here to find out the nth term from the end of a GP. We know that second term from the end can be calculated by dividing the last term by R. R means it can be written as R power 1. In order to bring this value in the formula, we are writing this one as 2 minus 1. Hence, second term from the end can be calculated by L divided by R power 2 minus 1. Now we need to calculate third term from the end, means L divided by R square. This 2 can be written as 3 minus 1 because this 3 is here. In order to relate this value in the formula, we are writing like this. Similarly, fourth term from the end of the GP can be written as L divided by R power 3. This 3 can be written as 4 minus 1. Similarly, we can write the nth term from the end of a GP as L divided by R power n minus 1. I hope you understand this formula. Nth term from the end of the GP can be written as L divided by R power n minus 1. In order to find this value, we need the last term and the common ratio and this n value. If we know these three parameters, we can find the nth term from the end of the GP. I hope you understand this. Now we are going to solve problems related to it. Find the 8th term from the end of the GP. Here GP is given as 3, 6, 12, 24 and so on. 12,288. In order to find the 8th term from the end, we need three parameters. One is L, next one is common ratio R, and n minus 1. Here n value is given as 8 and last term is 12,288, and common ratio can be calculated by dividing 6 by 3. So we get common ratio as 2. So we can substitute these values in the formula. So 8th term from the end can be calculated by writing L divided by R value is 2, and then power n minus 1, 8 minus 1 is 7. So when we simplify it, we get the final answer as 96. I hope you understand this problem. Due to the time limit, I am stopping the video now. In the next video, we will continue to discuss geometric progression. Thank you students. Thanks for your cooperation.